All right, thanks. So yeah, Dan Kirkendall. I'm the co-CEO and CTO of NT Objectives. We do web app scanning. Our key product is NTO Spider. And we focus mostly on web apps, but we've been kind of branching out into dealing with mobile. So a lot of this talk is really going to be about dealing with a lot of the mobile apps. And then I blog over at manversuswebapp.com, podcast off of there as well. So feel free to check that out. All right, this talk is titled Hacking Fantasy Sports, but it's really much more than that. It's really just kind of about a way of starting to attack a lot of the newer apps that I'm seeing. So we're going to kind of go a little bit over some mobile hacking 101. We're going to cover the 7 deadly sins, and I'll get into that. And then we'll do some I'll show you some hacks that I've actually done against various mobile apps, and we'll wrap it up. So the first part of it is just understanding how to do mobile hacking and where to really start, how you get set up for this. One of the things that I really encourage is to look beyond the device in your hand. A lot of people are focused on the mobile binaries, and there's some privacy information, there's some local storage issues that they have, but by and large, I don't think it's as interesting as what's going on behind the scenes. Usually these apps are talking to a server, and that's really what I want to look at. So that's what we're going to break down, is looking at how to start looking at that traffic, what it looks like, understanding the session management issues, and then start doing the hacks. So the first is to just get in there and start looking at the traffic. One of the best ways that I've found is the Wi-Fi Pineapple. This is a very portable little device. This is the older version, the Mach 4. The Mach 5 is the one with the 2 antennas. But this little guy is a very portable Wi-Fi hotspot that's running a little Linux platform. You can set this up so that you've got, what I'll do is take this setup where I've got my little Wi-Fi hotspot, from my mobile network provider, take that with my laptop, run in Burp Proxy, hook up the Wi-Fi Pineapple, and now I can start broadcasting as like ATT Wi-Fi, right? And start offering real internet access from my device. So I'll sit down and I'll set this up at the mall and turn it on, and all of a sudden tons of devices start connecting to me, all right? Because one of the nice features of the Wi-Fi Pineapple is Karma mode, where you can actually set it up to listen for any other connections. So if a device is looking for an SSID, doing the probes, looking for their home network or whatever, it'll actually respond and say, sure, that's me, right? So you get all kinds of devices connecting to you with the Pineapple. So that's a fantastic way to do it. Very portable to set this all up, and a few little Linux commands to set up a transparent proxy, so you can force all of the traffic through. And by the way, my slides will be posted. They're online, so if anybody wants those. But pretty easy to route all the traffic to my box where I'm running my Burp Proxy. So all the port 80 traffic, all the 443 traffic is going through me. So I'll sit down at the mall with this, okay? And get all these devices connecting and just start sitting there watching and start saving everything that I'm seeing. And I'll go home later and use this data to kind of analyze what's going on, see what sessions I can take over, and all kinds of stuff. We'll get into that. So I'm going to be giving away a few of these Wi-Fi Pineapples, I think 2 or 3 of them. So if anybody brings me their card, if you don't have a card, write down your name and email address. Just drop it off up here either now or after the talk, and I'll be giving away a couple of these. We'll draw from a hat kind of thing. So when you start looking at the traffic, you have to figure out what you're looking at. A lot of these formats are different. A lot of us are used to web apps and the standard name equal value format that we see in the web apps. That's kind of what we're used to doing. Looking at. Used to taking that and doing some various attack payloads and trying to do standard web security attacks. Okay, that's what we're used to, and we'll still see some of that format. But mobile apps, we start having a lot of new traffic that's out there, a lot of new formats. We'll still see the name equal value, but you'll start seeing a lot of JSON traffic, REST, AMF. I'm going to get into some of these here. But you'll start to see new formats, and you have to start understanding what they are and how to deal with them. They're really not that complicated, but you have to get comfortable with them. Once you get comfortable with them, it's easier to start attacking. So JSON is probably the most popular that you're going to see. JSON is kind of like XML in that it could be, you can have very nested structures. We refer to it as the fat-free alternative to XML. It's a very lean way of sending the traffic. By far the most popular for mobile apps. You see this with Ajax apps, and when they talk to their backends, you see JSON in a lot of places. Originally it was created for JavaScript, but now it's just used as a good format. Normally, what you'll see is like on the bottom here. It's usually one long string that may look, scary, but it's really easy to understand. Up on top, I formatted it so it makes it very easy to see how it's, it's a nested data structure. And there's lots of data that can be passed along in there very conveniently. So when it gets parsed, it's, in a nice little, multi-dimensional array or a struct or something. It's nice to deal with. JSON can be sent in different places. You could see it being sent as a parameter to like the standard name equal value, and it could pass in the JSON. You see it in post data. You'll see it in different areas. People will plug it in anywhere. But once you kind of look at it and you start getting comfortable with it, it's easy enough to deal with, because ultimately there's still parameters that are being passed to the back end. So you have REST. We hear about REST a lot, and RESTful URLs, RESTful web services. REST is not a specific standard. It's just kind of a style of doing things, of making things kind of easy to look at it from a human view and deal with, and have programmably usable data in many cases. You can see, RESTful URLs like up on top, where the directories are actually just parameters. You'll see kind of a mix of it with classic formats. You'll see it sending back XML. Sometimes it'll be sending back an XML response. It could be sending a CSV response. The responses can vary. Sometimes you'll see mixed, where you'll send a classic name equal value pair as your get, and you're going to receive a JSON coming back. RESTful backends can do any number of things. Google Web Toolkit's got its own structure where it's actually just like value pipe, and then it usually responds with a JSON coming back. So all these formats are going to look a little funky. It looks a little different than what you're used to in standard web security and web pen testing. But idea here is just get comfortable with it. It's not too big a deal. One of the ones that is a little odd is AMF. This is the Adobe messaging format, or ActionScript messaging format. This is what Flash, FlexApp's native RPC format is. But the thing that's nice is there's decoders in just about any programming language you're going to need. So, normally you're going to have like a web page that's loading up a Swift file, and then the Swift file is going to be sending AMF packets, and they look very binary. So you'll see these kind of binary objects being passed, or these serialized objects. But they're decodable. Even Burp Proxy supports it. So you can kind of decode those requests, see the values, modify them, do a SQL injection. It'll repack an AMF request up and hit the back end. So it's easy enough to deal with these things. So quick question, anybody know what format this one is? No. This is JSON. So there's a lot of data, but it's just a JSON request. This is actually the banner ad request from Words with Friends. And it's got a ton of information in there. My little light's going to work, but it's got like what carrier I'm on, what type of phone I'm using. Somewhere in there is the word that I submitted on the board of my Playing with Words with Friends. It sends all kinds of information. So you could even actually have banner ads that would be context sensitive to what you just put on the board. But JSON is very convenient for mobile developers because it allows them to send a lot of data very compactly in a compacted format. So when I started looking at the fantasy football app, I wanted to look at, I play fantasy football. Are you guys familiar with fantasy football and what it is? One thumbs up. So We liken fantasy football to D&D for sports geeks, right? Really not that much different, And what you basically do, for those that don't know how this works, is usually at the beginning of the season you pick your cast of characters. Each of the teams kind of take turns picking players from wherever in the league they want, trying to get the best players. And then during the season, you kind of set your lineup. You figure out which of your guys are the best on any given week. Once in a while, a player's going to get injured or they're going to have a bye week. It's kind of like their vacation week. So you kind of manage your roster every week to figure out your best guys. And then they start playing, and usually in a head-to-head matchup against another team. And whichever team's players get the most points wins, right, for that week. This is me playing against the Denim Group. I got a hacker league going. So I beat them that week. That was nice. But each player kind of gets points based on how they contribute. If they're a wide receiver, how many passing yards they get and all that sort of thing. So it's important for fantasy football players or fantasy football managers or fantasy baseball, there's all these different fantasy games, to kind of set their lineup and get it right. And usually we get it wrong, and then we make a whole lot of excuses as to why our team sucked that given week. All right? And then we also spend time trash talking when we do well. Right? So it ends up being very key. So I started looking at this, and I was figuring, I wonder how secure these things are. And I started looking at the traffic. I looked at the web app itself, and it was pretty secure. They're really, I was doing a lot of the standard attacks. I wasn't really finding anything interesting. And I didn't want to spend a lot of time. I'm lazy, so I decided to take a look at the mobile app. So I'm looking at the mobile app. It gives you a lot of the same capabilities. I can go in there, I can see what's happening, I can modify my lineup right from the mobile app. So I want to look at how it's doing that. How is it talking to the server? So I got my Wi-Fi Pineapple all set up, got everything going, start looking at the traffic, and what I start seeing is that it's making these requests, and it looks like, look at this, Q equals update fantasy sports internal, right? And it's got some big long string, where, path, what does that look like? SQL statement, right? So I'm like, okay, that's cool. So I want to start playing with this. And I started doing some attacks. I didn't find an easy way to do SQL injection. Apparently they're using something called YSQL. This is Yahoo's backend. And so it wasn't easy to do any real good SQL attacks. But I started looking at what's it actually sending? What's the data that's being sent? And that green string, I spread it out. It's just an XML document. Right? It's got the player ID's number and their position. So it shows their starters up there, and then they got some guys on the bench, the guys in the red, right? So I'm starting to look at that, and I go, okay, this is all it's doing. Every time I change my roster, this is what's happening. So doing that against myself isn't as fun. So I wanted to start understanding more about what's going on, and I started doing an investigation on really what, how can I mess with other teams, kind of knowing this information? What would I do? So it kind of led me down a path of understanding how mobile apps communicate and how they manage their sessions. And this is really where the 7 deadly sins of mobile app session management comes into play. I want to understand, how do they authenticate users and do this right? Where do they do this right and where do they do this wrong? So I broke this down, and basically what you have is, one is that you're trusting the client, okay? So that's usually the first step that they do wrong. They don't always require encryption. I'm going to go through each of these here. But allowing lifetime sessions, not keeping secrets, allowing repeat requests, no curfew on these requests, and then failing to prevent altered requests. So I start looking at kind of where are the mistakes they might make. First one always is trusting the client, okay? It always starts here, they build the mobile app, and they also build the back end. They kind of trust that the traffic would only ever come from that mobile app, and that's where the mistakes always start. Okay, so that's number one. Number two is not requiring encryption. I see a vast majority of apps are not doing any kind of SSL. They're just running over straight port 80. When you're using a mobile app, you have no idea. It's not like a browser where you have that little lock icon that tells you that you're on a secure site or not. There's no analogous feature in mobile apps. right? You're just left unaware. Unless you start looking at the traffic yourself, you have no clue. I also see that a lot of ones that are using SSL do it wrong, and they don't require a valid certificate. So if I'm using Burp, if you ever used Burp Proxy before, it has its own SSL cert, right? Most apps will take the SSL cert from Burp just fine. They're not doing any kind of check. I've seen some that do check and do want a valid cert, because it's a little bit they set in, when they're doing dev. And a lot of times they'll turn it off because they want to use their self-signed cert. But if you're man in the middle, most of them that are checking the cert and do want a valid cert, they don't do they don't check the cert authority. They just kind of accept that cert on its word, and so they don't check the cert authority. And if you're man in the middle, you can kind of cheat on some of that unless they're doing SSL pinning, which most are not doing. So simple SSL strip type of stuff works really well. So, and the Register actually did their own. They had pretty similar results. I think they actually think it's worse than I do, but you can look at that article if you want. So anyway, that was number 2. Number 3 is allowing lifetime sessions. Mobile apps tend to allow a session to last a very, very long time. And there's reason for this. A lot of users just want to click on the little button, have the app launch, and do what it's supposed to do. They don't like entering their password every time. And the form factor of a mobile device is terrible for entering a password. So people don't like to do it. And when they are forced to do so, they have really weak passwords. So mobile app passwords are pretty bad. I also see some apps that are using the wrong type of information to authenticate the user. I've seen some that'll use the IMEI of the device, right? It's kind of its social security number, or it's a little card number, to identify that user. And that's a terrible mechanism, because those are so easily stolen that once I know that, it's open season. And I'll get to one of my hacks later that kind of depend on that. And that I found some interesting stuff there. So this not timing out the session is a problem. They also don't keep secrets. In the web security world, we've kind of been stuck with the fact that the only data you can really store for really managing a session is like a session cookie. You can't really store any secret data on a browser. And so if somebody's man in the middle and they can see the traffic, they can steal the session ID, and we're just kind of like stuck with it, right? HTML5 starts to answer some of that. We can actually have some local data store stuff that won't get sent in every request. But mobile apps have that inherently. They can store data on the client that can be used to assign requests or do things. They're not taking advantage of this. So once you're man in the middle, you can see everything. It's open season, right? You can steal a session very easily. The other thing that we see that they do wrong is they allow repeat requests. They allow the same request to be sent over and over. And there's not a lot of good reason for this. But what they're not doing is like kind of tracking the requests and maybe signing them with a nonce, right? A number used once, so that when they send it, the server would have a list of all the nonces you've used, and if it's one that you've used already, it would reject the request. Know that I've already got that. Because again, if I can become man in the middle and I can capture your request, and then I can resend it, that might be something I can do. I actually found this worked with Twitter. They've recently updated their API, but in their old API that was just barely shut down in May, okay, that old API allowed you, they don't track nonces, and once I captured a request, I could resend it later. So if it's Twitter, that's annoying if I'm just resending the same tweet, right? If it's a banking transfer, that's really cool, right? That could be a real problem, because I can resend it. And it's pretty easy to solve by just tracking the nonces. Keep track and store them on the server, okay? Now, when I talked to the guy with Twitter, and actually with Twitter, I was doing this at B-Sides RSA. I was doing a live hacking demo and started seeing Twitter traffic. And I was even able to see their direct messages. So, they check their direct messages. After that, I could monitor their direct messages for a good long time. So that's not so good for them. But they fixed it. They've changed the way their structure works. But anyway, nonce is a good solution. Most aren't using them. The other thing that they don't do in many cases is time out a request. So a given request, I've recorded it, I've maybe stopped it from being sent. Let's say I'm man in the middle, I prevent it from going forward, I want to keep it for myself. I can go ahead and do that and actually see that I can send that request hours or days later and it's still going to work. Again, if let's say it was a bank transfer and I held it and then it resent it, and it created a new one and sent it, and got that bank transfer to go, I still have this one, I can send it later and it would still work. That's problematic, right? There's reasons that they do this. A lot of it is around connectivity. Mobile apps have to accept that they're going to lose connection from time to time. You're going to be in an elevator or whatnot, you're going to lose connection for whatever reason. And so what most do is they'll hold it and buffer until it gets, it's able to go out. And they should really time these out. And I'll kind of explain a little bit why, but one of the things is if you tie this to the nonce, let's say you say that request is only valid for an hour, okay? And if it doesn't get sent in an hour, the app should just regenerate a new request. That one should expire and it should regenerate a new one. If you do this, then your nonces on the server only have to be stored for that lifetime as well. If you know the request is only for valid for an hour, I only have to keep an hour's worth of nonces on the server. So it kind of saves you some space there. So simple time stamping of the request and expiring it, very useful to do. And then the final thing is preventing altered requests. Most apps, once they kind of set up their session, if it's Twitter, and let's say a Twitter example, if I could change the content of the tweet, that's kind of fun, right? I can kind of mess around with people that way. If it's a banking transfer, and I could change the account it's transferring to, that's a lot of fun, right? And it's easy enough to tie some of these things together to prevent all of this, right? If I were to have that secret token, let's say when I set up my log in or whatever, I do some kind of PKI exchange or even just a randomly generated shared secret between the client and the server that never gets transmitted after that initial setup. I can then sign everything. So I could take my request, I could take the user content, I can take the nonce, the timestamp, kind of hash all of that and encrypt it with my secret key. So now I'll have a secret hash that only I could have generated because I would be the only one with the secret key, right? So I could take all of this, toss it in my request. So, let's say I've got the session cookie, I've got the timestamp, a nonce, I got my secret key, there's the content. The server could then validate that very easily and make sure that nobody else could have generated that request or altered that request in any way. Twitter was doing some of this content hashing, so that's why I couldn't actually change the tweet text. But if you do this, and you do all 7 steps, and you're doing this also over encryption, so it's, the encryption is solid, and then of course you want to make sure you're doing, standard like SQL injection protection, you end up with a very good profile, okay? So these are the kind of things I recommend for how apps should be built and how they should verify sessions and verify the user making the request, okay? And I don't know why it changed the formatting, all this is weird. So those 7 things, kind of the never trusting the client, using encryption, limit the session lifetime itself, using secret keys, use a nonce, timestamp these requests, put all these together, you have a pretty good secure mobile app. So then now I got to spin this around, right? Let's go back to hacking fantasy football. What of these 7 are they doing or not doing? Okay, I started looking at it. Started looking at the fact that the sessions last a very long time. I never was asked to re-log in for an entire season. They were not using SSL. They had no nonce type of activity, no secret key hashing or signing. So all I really needed was a session token. So again, SQL injection wasn't working, but I knew all I needed at this point was the session token from another user. And then once I did that, once I had that, I could actually do a lot as them, right? I could change their lineup. So I wanted to get session tokens. So what I did, I waited and I was patient. And draft time was coming up. And so who do you think provided Wi-Fi access on draft day? Right? So I collected all these session tokens. And I had everybody's, well, one guy, he was doing it off his device and he had his own connection. But everybody else, I was able to grab their session tokens. Once I had their session tokens, I could do a lot. I was them as far as the back-end system thought. Simple session tokens is all I needed to go in there, take their lineup, right before game starts, swap the starters with the bench, right? Send it, and then they're screaming and crying and having a fit, and they have no idea how this happened, right? And it's just because the back end was not doing this right. I had to report this to Yahoo. They have a new app. So what's interesting with Yahoo is the new app actually works. The new API is much better. Uses SSL. It does time out the things, but the old API still works. So anybody using the old app is still exposing themselves. But it's harder now to steal session tokens because most people have updated. But going through this process of looking at those 7, right, those 7 deadly sins and breaking them down is what I've been spending time with, looking at lots of different apps. And I found lots of stuff. The fantasy football one's a lot of fun, but there's a lot of interesting stuff that I end up seeing as I go through this process, as I go through looking at what's available, what can I do with these apps. A lot of apps are, they're not using encryption, and then they're using like basic auth for their authentication, right? And any of you know, basic auth is just like a base64 hash string. So you just base64 decode it, and you got credentials. I was able to steal some traffic or some data. So My Backup Pro and Address Book Pro, they actually ask you, at least My Backup Pro does, it would ask you for a password when you'd open the app, right? And so you have to plug in your little password, and then the app would actually load or show you your data. Looking at the traffic behind the scenes, that password is not used for the communication with the server. It is just used on the client just to make you think you're doing something, there's some kind of security involved. Behind the scenes, it's actually using static passwords for everybody. It was like My Backup Pro when I did the base64 decoding for every request. And it was using the IMEI as the identification for that device. So then I collected a bunch of EIMIs, whatever. I collected a whole bunch of those, when I was doing my mall setup, and then I just went to My Backup Pro and just cycled through the list of them that I had and found all kinds of people's data. There's so many people using that app, it was ridiculous, right? And there's really no security involved. I was playing Words with Friends, and this is kind of earlier in my process when I was doing it. Words with Friends is not vulnerable to this anymore. But I was able to do word bypass, word verification bypass, because they have a request when you submit the word on the board. You guys all familiar with Words with Friends, right? Scrabble. When you put your words on the board, it was making a request to do a dictionary lookup and see if it was a valid word. So I looked at the response, when I put a valid word, and I did an invalid word, and they had different responses. So I saved the good response, right? And then I took all 7 letters, dropped them on the board, intercepted the response, put in the good one. It accepted it and actually sent it and put it on the board, right? And I was playing my cousin. He's freaking out, right? He's like, calls me up immediately. What did you do? And I won that game. So, but it's like going in and starting to look at this traffic and looking at how are they verifying this? What are they doing? And Words with Friends now, what they did is they combined the request. So it's one request to submit it. But what's actually nice is in the response, if you put a word that's invalid, in the response, it has a list of words that are close to that you could use. So it's like a real suggestion box right there. Like, oh, dummy, I should have used that one. So it's a good cheat that way. I was looking at other apps, and you'll do some standard SQL injection type of attacks too. I mean, this is Associated Press's mobile app, so you can monitor the news, right? And it's got a little RESTful back end that it would send data to and get a nice little JSON response with all the data that it's going to show in the app. So I look at that little count equals 10, think, well, maybe do a little SQL injection attack, and sure enough, I'm getting SQL errors, right? A lot of this is because the people developing these back ends, they're not thinking of them as, even as, web developers make this mistake all the time, but even more so when it's done something through an API that really people don't directly interact with. So I see some interesting stuff there. I don't know how much time I got left. How much are we at? Oh, geez, it's early. I'm going fast. Bump was an interesting one. I don't know if you've seen this hack. MJ Keith was the one that found this. You guys familiar with Bump? It's kind of an older app now. But it was popular for a while. But what Bump would do is, it basically transfers contact data. So you have two phones, and let's say you're at a conference like this, and you meet somebody, and you say, okay, well, let's bump. So they bump phones, and they get each other's contact information, right? So it's kind of like a way of transferring a V card. So what was interesting about this is it's not sending phone to phone, okay? It's sending to a server. And these servers, what happens is the two devices they bump, they have the event, and so they'll go and send to the bump servers, say, hey, I just got bumped, and this is my location, and this is the timestamp, right? And so the bump server will then pair you up based on proximity and time of the bump, right? So they would match them up, and then you'd get each other's information, and you're good to go. Well, location is sometimes fuzzy, right? We don't necessarily, GPS isn't always on, it's not always accurate. Sometimes it's using like your tower's location. So there's some fuzziness. So what we noticed in the request from each of the devices is it had an accuracy space. Like one of the values was how accurate the GPS coordinates were. And there wasn't a lot of boundary conditions there. So what we did at that point is we were looking at the Moscone. That's where the conference center they do RSA conference at. So we got the GPS coordinates there, and I started sending requests up myself. I wrote a little Perl script that would, on my high-speed connection at home, would just cycle through and say, I just got bumped. And I would make my accuracy rating like within 3 miles of the Moscone, right? Which is a good space, right? And I just let it run. And what I started seeing is that I would get bumps, and I would get matched up with people. And so, and you have that, now it's like, okay, what would happen if I respond with like a bunch of, error. So I created a V card that was just all junk. It was all error. What I would do is I would respond with that. I would get their information, I would have that. I'd send back error. Then what I'd see is they'd bump again. What I'm assuming is they would be sitting there going like, what the hell? Let's try it again, right? So now, let's say these two guys bumped, right? I already took their information, I gave them errors back, they do it again. Now I can go ahead and send back each other's data. But I've got the stuff here, and I can modify anything I want. I can change a phone number, I can add a malicious link as the company's URL, I can do whatever I want there, right? There was nothing in Bump's system that's actually, they weren't storing your contact information on their server, they were getting it sent on the moment, and they weren't verifying clients in any way, they weren't having any request signing, there was nothing. And MJ Keith actually took this further. He had found a Safari bug, an old Safari bug from the desktop Safari that still worked on the iOS Safari, and was able to get remote shell, a link that would exploit Safari and actually give him remote shell on the iOS device. Fantastic, right? But again, it's just first exploiting these APIs, because this is our gateway to the mobile client. This is our gateway to all kinds of valuable data and lots of fun stuff. So the main process here is to start looking, right? Look at these apps. I think the mobile market is really the emerging market, and I don't think it's necessarily on the client side either. Look beyond that device in your hand is really the key. Start watching the traffic. How many of you have been kind of looking at this mobile traffic? How many of you have been starting to test it? All right, we got a good few hands. It's very easy to do. It's actually a lot of fun to start looking. Like, look at your own device. Start looking at, connect it to a local hotspot, local Wi-Fi, and start monitoring the traffic. There's lots to do. For you that have been looking at the traffic, has anybody started hacking apps and seeing this type of thing yet? Seeing some fun stuff? Very cool. So again, these 7 are going to be the key. If you want to win a Wi-Fi Pineapple, we'll ship it to you. I don't have them on me, but we'll get them shipped to you pretty quickly in the next couple days. Just bring me your card up here, and that's pretty much it. If you want a copy of my slides, I've got them posted. I'm going to have them posted here. I'll keep this URL up. Any questions? So I guess we can go to the question and answer time.
With regards to authentication, what mechanism would you recommend, properly using?
When you're building an app, like how should...
Right, instead of using MDN or IMEI, ICCID, whatever.
Well, I mean, a user password type of solution is still fine for that authentication piece. Of course, you want it over SSL. And what I recommend is after that, you should kind of also have some kind of key exchange so that the request can be signed in the future. But standard name and password is fine. I don't see any issue with that by and large. It's just what you do after that. Once you've established a session, how are you going to maintain it? And I do see that most mobile apps have very, very weak password strength policies. And again, I understand the form factor of a mobile device is terrible for entering a password, but we've gotten too laxed, I think, with mobile apps.
So while you're testing these apps, do you do anything to avoid getting into trouble, like you store for all your requests and stuff, or just...
most of it, so, okay. I did talk with legal about my setup, hanging out at the mall with, an open hotspot. And I don't really have a EULA, I don't have any kind of user agreement on the Wi-Fi hotspot, and people are connecting to me, and I'm giving them real internet access. And the default policy on privacy really doesn't exist. So, it's not like I'm joining somebody else's hotspot and stealing data. I'm offering, and people are just making but going and attacking the individual apps, I think is, that is a little risky at times, but I do soft touches. I've been doing this a long time, and then we have clients that have mobile apps that I've been testing. None of these are from our clients. These are ones I've just found in the wild or been testing. And then I've got some guys on my research team that are in different countries, and they don't really care.
So how exactly do you pull that JSON blurb from the beginning?
The JSON traffic?
Yes.
Well, so it's just about being man in the middle. Once I'm man in the middle, I can sit there, go back on my slides quite a bit. Let me back up here. Farther back than I thought. So, kind of setting this up here. So what I'll do is I can either use the little one in the corner there is my T-Mobile hotspot, but I can have like my laptop hooked into my LAN, and then have the Wi-Fi Pineapple hooked up to my computer. So now I'm running Burp on my computer. It's running on port 8080, right? So the Pineapple will be a hotspot. So you just take your phone, you connect it to the hotspot, to the Wi-Fi, turn off your mobile data network, right? So now it's going to force all traffic through the hotspot, and you'll just start seeing the traffic coming through in Burp. And so you just go through Burp and look at your proxy log, and you have it all there. You can use Fiddler or whatever proxy you want. I happen to use Burp. I like it. But it's easy enough to start getting it, and you do your own device. I'll do a lot of stuff with my own device, installing apps, using it, watching the traffic, and there's few apps that are not using a web server backend, and so you have to look at the traffic in Wireshark, and that's miserable. But if you're not adverse to hanging out in Wireshark, you can kind of look at traffic there too. But most traffic is web.
Two things. One, because you have the slide up. So some of these Wi-Fi services, once you've authenticated, you also get all that user's emails and things like that. I guess a good reminder, people shouldn't have their email and their Wi-Fi account be the same account, but it is.
Yes, yeah. The shared password thing, all the standard security stuff does come into play. And I do see that, like when I've seen credentials being passed. I focus mostly on the web stuff because it's just kind of my own personal interest. But yeah, if I'm watching Wireshark and I see them connecting to a POP server, now I've got a password there. Once you're man in the middle, you can do just about anything you want at that point, right? And by the way, on the laptop, I actually I'm doing internet connection sharing, and you can either do that with Windows or Linux pretty easily. So it's an actual router giving real internet access, and then I'm just forcing the port 80 and 443 traffic through my burp.
And I noticed in the fantasy football SQL, there was a date code.
Yeah.
Could you retroactively, after the game, change the date to before the game and sort of do very well on that one?
I haven't tried. I'm going to now. That's a good idea.
What kind of storage encryption would you suggest?
So, hey, so he asked on the local device, if you're going to have like the secret key that you're going to store on the client, how would you protect that?
Tokens, like authentication tokens, host tokens.
So authentication tokens, host tokens. Are you talking about like the SSL pinning type of stuff?
No, I'm talking about application level security.
Okay, so just
Most possible, for example, the common practice is to keep it to very long period of time, like 6 months, 3
Right.
months. So how would you protect it?
So what I've seen, and there's lots of ways you can solve some of this. So if you, let's say once you get in, you have your session ID, and let's say you have your secret key, you can still, even the simple thing of just cycling the session token every once in a while when it connects, kind of like a set cookie event that just gives it a new session token so that old traffic is no longer valid. And then that's the data that you're going to store on the client. I don't really mess with that too much, like how you're going to store it there. That's really not where I've played. I was listening to a talk earlier, and they've got all kinds of solutions on how to store data securely on the device so that other apps can't get to it, make sure it's in your sandbox space and all that sort of thing. And there are hacks that are going to allow you to bust out of the sandboxes and stuff. So I don't know how you're going to do it, but in that end, but that's the individual client. I think that's it's harder for an app to steal that, and you're only targeting an individual client. But oh, and losing their phones? Yeah, that's another reason why you want to time out the light, and ask for the password again every once in a while. Yeah, lost devices are a real problem. And that's another thing, is like Facebook has a feature where you can go in and see a list of your active sessions and then you can kill them. Most apps don't do that, you should. You should be able to it's like when you lose your credit card. You can call the credit card company and say, get rid of it, right? Kill that account. Give me a new card. But most apps don't give you that capability, so that's a good point.
So let's assume you set up a rogue access point and intercept the traffic with Burp Suite. If it is an SSL connection, wouldn't it prompt you for the certificate, like the mobile app, that you are connecting to a site with a fake or...
So most apps don't, actually. A lot of them haven't built the interface, or they're not using the library properly. And so that's what I was saying, is a lot of them will accept any cert. They just want to connect to an SSL connection, and they ignore the cert errors. And usually it's because during dev, they've done like a self-signed cert against their local box or whatever, and they didn't install that cert onto their device. They just kind of like turn off the error handling. So I see a lot of them just turn off the error handling. Very few have the dialogue that'll pop up. Very, very few.
So in that case, you can actually break the SSL connection and then read that, and before you forward that again to the destination, right?
Yeah, exactly. Burp will be man in the middle, and it's the SSL server and then the SSL client, and in the middle is pure, plain text.
So last question, how do you force the mobile app to talk to your proxy?
So in this here, what I did here was like set up the device to force all of the port 80 traffic through my box, which is the 172.16.42.42 port 8080. That's where I got Burp running. So I'll force traffic through there, and I'll just add another line for destination port 443. And then all of a sudden I've got the traffic going into Burp.
Right, I have one. Can you go back to the slide where you showed a bump?
Bump? Mm-hmm. Well, that's toward the end, so let me jump. All right, well, let me just zip through this.
Yep, there you go. So I was a little confused here. So are you being a man in the middle between two contactees and then
No.
your...
I'm not man in the middle on this one. This one, all I did was I had a Perl script running on a high-speed connection that's going and just saying I got bumped, I got bumped, I got bumped, I got bumped. And then if somebody actually does bump, I'll often win both races and I'll get matched up.
So it's more a race condition.
Yeah.
Okay.
Yeah, it's a race condition problem. And, and then I can end up getting in there. Any other questions?
Were you able to find any parameter or vulnerability that could possibly allow the 49ers to overtake the Seahawks, or is that seems impossible at this point?
It does seem impossible at this point, and we're hoping we get to the playoffs. But, I figured, well, I'm in New York, I'm going to go grab a, either a Giants or a Jets shirt, but I just couldn't bring myself to put one of those on. So, I'm a California guy, I'm going to just stick with it. Anything else? All right, well, thank you all then.
Thank you.